Our new standard asks us to be able to solve a system of linear equations, not by graphing this time, but by substitution. Let's walk through the scale that we're going to be working with. In a level 1, we will be asked to solve by substitution when both equations already have a variable by itself. And it has to be the same variable that's already by itself. In level 2, only one of the equations will have a variable by itself. In level 3, neither of the equations will already have a variable by itself, and you need to be able to identify solutions when they are infinitely many or no solution. Remember our special case solutions. And finally, a level 4, you have to apply this to a real-world scenario and solve the system. Let's walk through the basic steps to solve a system by substitution. You may want to pause the video and write this down. But to solve a system of equations by substitution, we're going to follow 5 steps. Solve one equation for one variable is our first step. It's in your best interest to always try to look for a variable that doesn't have a coefficient. That's a number in front of the variable, because it'll be the easiest one for us to solve for that variable. And it will also help us avoid having to deal with fractions. Step 2. Substitute the expression from number 1 into another equation. Number 3, we're going to solve for the remaining value. So we'll end up solving for the variable that's there. And then use the new value from number 3 to plug in to find the other variable's value. So write your answer as a point. Now that's a key concept for us to understand, because when we were graphing, it was kind of a given that all of our answers were written as points. But as we move into more algebraic methods, we need to remember that we have to write our answer as a point, because remember, the solution is where 2 lines cross, and that is a coordinate point. Let's work through our level 1 example. For the first example, we have 2 equations. Both of them are already solved for y. In this template, we're going to write our 2 equations down in the box. So these are our original equations, and we ask ourselves a question. First, it's asking, is there already a variable that's isolated or by itself? And the answer is yes. Y in both equations is already by itself. So since it's yes, we'll follow it over to this box here, and we'll write our equations down again. In this box, it asks us to substitute the expression for the isolated variable into the other equation and then solve for the leftover variable. So we're going to take this expression here that it said that y equals x minus 3, and we're going to plug it into the other equation for y. So we have x minus 3 replacing y, and it's going to equal 2x minus 5. Now we can just continue and solve the rest of the equation. So we will subtract a 2x from both sides, leaving us with negative 1x. Minus 3 equals negative 5. Then add 3 to both sides. So negative 1x equals negative 2. And finally, we'll divide by negative 1 on both sides so that x is equal to positive 2. Okay, and if we go back to those 5 steps that we were following before, it wants us to take this value, this 2 here, and we are going to take and plug it back in to this original equation for x. So here's our original equation. We are going to take this 2 and we are going to plug it in for x. Now, we also need to realize that this 2 is already part of my solution. It belongs, since it was an x, in the x coordinate spot. So plugging in the 2 in for x gives us y equals, and I'm plugging in 2 for x, minus 3. 2 minus 3 is equal to negative 1. So the other part of my solution is negative 1. So if I were to graph these in standard 1, I would have 2 lines that crossed at 2, negative 1.